What if the numbers carried the culture of Batangas? Introducing the Alae Numeration System.
Alae Numeration System, also called the Batangueño Numeration System, is a culturally inspired way of representing and interpreting numbers. Unlike the conventional decimal system that uses the digital 0 to 9, this numeration system incorporates Batangueño cultural icons as symbols to represent numerical values. This positional structure means that place values in the Alae numeration system represent powers of 5. The first position is the ones. 5 raised to 0 is equals to 1. The second position is the 5s. 5 raised to 1 is equals to 5. And the third position is 25. That 5 raised to 2 is equals to 25, and so forth. The symbols of ancestral churches, balisong, lomi, lechon, and kapeng barako encapsulate the rich cultural heritage and socio-economic history of Batangas, a province famed for its traditional methods, craftsmanship, and culinary traditions. The symbol for 0 to ancestral churches, representing faith and the starting point of communities. 0 is linked to beginnings, much like churches were foundational in Batangueño society. The use of heritage sites such as the Taal Basilica and San Sebastian Cathedral and Balayan Batangas Church connects the numerical to cultural identity. It reflects resilience, devotion, and the deep historical roots of Batangas. The number 1 represents a new beginning, uniqueness, and the start of something significant. The balisong or butterfly knife is the iconic symbol that embodies craftsmanship, ingenuity, and identity of Batangueños. Just as the number 1 marks a distinct starting point, the balisong stands out as a unique cultural treasure of Batangas. The number 2 represents associated with companionship, partnership, and togetherness. The Batangas Lomi dish represents this sense of community and shared experiences. The number 2 reflects how Lomi is best enjoyed in groups, bring people together, and over-nourishing meal. The number 3 symbolizes balance, harmony, and the Trinity. The lechon or roasted pig is a symbol of abundance and festivity that brings people together in celebrations. The balanced number 3 mirrors how lechon is central to many Balayeños or Batangueños gatherings and traditions, fostering a sense of unity and joy. The number 4 represents stability, structure, and the 4 cardinal directions. Kapeng Barako, the bold and strong Batangas coffee, is a foundational element of the region's agricultural economy. The number 4 reflects the stability and enduring presence of this iconic product, which has become a source of pride and tradition for the Batangueños. Place value in the Alae numeration system. This slide explains that the system is positional, with values determined by powers of 5. The chart shows how each place values increases 5 times as it moves leftward, 1s, 5s, 25s, and so on. This mirrors how the decimal system uses powers of 10, but with 5 as the base instead. It emphasizes that each position multiplies the previous by 5, creating larger numbers efficiently. This system demonstrates how mathematical bases can be adapted to different cultural contexts. Arithmetic in the Alae numeration system. Basic operations such as addition, subtraction, multiplication, and division are performed in the same logical manner as other positional systems, like decimal or binary, but expressed through Batangueño symbols. For example, in the base 5 addition. In decimal, 2 plus 3 is equals to 5. In Alae numeration, Lomi plus lechon is equals to balisong and ancestral church.
Addition. Our given problem is balisong lomi plus lechon balisong. In Alae Numeration System, it is 12 plus 31. And we solve this in base 5. First, 2 plus 1 equals 3. Then, 1 plus 3 equals 4. So the answer is 43 base 5. For the checking or verification, we convert first it into base 10. So 12 base 5 into base 10 is 7. 31 in base 10 is 16. Now, add 7 plus 16 equals 23. Then the 23 will be converted again to base 5. So the answer is 4 remainder 3, or in base 5, it is 43 base 5. Another example is Balisong Ancestral Church, Kapeng Barako plus Lechon, Lomi, Balisong, and Kapeng Barako. In Alaen Numeration System, it is 1,044 plus 3,214. First, add 4 plus 4 equals 8. 8 in base 5 is 13, so 3 carry 1. Then 4 plus 1 equals 6. In base 5, 6 is 11. So bring down 1, then carry 1. Then 1 plus 2 equals 3. Then 1 plus 3 equals 4. The answer is 4313. For checking, 1044 base 5 in base 10 is 149. Then 3,214 in base 10 is 434. Now add and the answer is 583. Then convert 583 into base 5 equals 4313 base 5. Subtraction. Our given is Lechon Lomi minus Lomi Balisong. In numbers, it is 32 minus 21. 2 minus 1 equals 1, and then 3 minus 2 equals 1. Therefore, the answer is 11 base 5. For the checking, 32 in base 10 is 17, and then 21 in base 10 is 11. 17 minus 11 equals 6. Therefore, 6 in base 5 is 11. Our given is Lechon minus Lomi Kapeng Barako. In numbers, it is 33 minus 24. Then 3 minus 4 cannot be, so 3 will borrow to 3. Then 3 plus 5 equals 8. Then 8 minus 4 equals 4. And then 2 minus 2 equals 0. For the verification, 33 in base 10 is 18. Then 24 in base 10 is 14. Then 18 minus 14 equals 4. So the answer is 4 base 5. Our given is Lomi Balisong times Balisong Kapeng Barako. And in numbers, it is 21 times 14. Then 4 times 1 equals 4, and then 4 times 2 equals 8. So 8 in base 5 is 13, so write 13. And then 1 times 1 equals 1, and then 1 times 2 equals 2. And then bring down 4, and then 3 plus 1 equals 4, and then 1 plus 2 equals 3. So the answer is 344 base 5. For the checking, 21 in base 10 is 11. And 14 in base 10 is 9. Then add both, and then the answer is 99. And then 99 in base 5 is 344 base 5.
The next example is division. So we have given L of Lechon, Kapeng Barako, and Balisong divide by Lomi. To divide this, we follow the same long division step as in base 10. But we have to remember to convert values into base 5 along the way. First is 3 divided 2 is equals to 1, then multiply it by 2. So it equals to 2. 3 minus 2 is equals to 1. Then bring down the 4, so it will be 14 in base 10, which is 9 in base 5. So we need to convert it. So 9 dividing by 2 gives 4, then multiply it by 2 is equals to 8. Then less the 9. So the answer is 1. Then bring down the 1. It makes 11 in base 10. Just like earlier, we need to convert it into base 5. So 11 will become 6. Then divide it by 2. So equals to 3. And 3 multiplied by 3 is equals to 6. Then less than to 6. So the answer is nothing. So putting this together, the answer is 143 in base 5. To check it, 143 in base 5 is equals to 48 in base 10, and the same as 341 in base 5. Then we have the fraction to decimal, and we have the Lome over lechon. To convert it in decimal is equals to balisong, 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 balisong in base 10. Since we are working in base 5, we convert it by multiplying the fractional part repeatedly by 5. Just like this. 0.666 times 5 is equals to 3.333. So the remainder, 0.3333, are going to multiply by 5 and the answer is 1.6665. And just like the earlier, the remainder of 66665 is multiplied by 5 and we would repeat it after 5 times, and this process gives us repeating pattern and the answer will be lechon, balisong, lechon, balisong, lechon. That is why the base 5 of 2/3 becomes 0.31313. Let's proceed to decimal into fraction. We are going to compute the balisong, 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 balisong in base 5. So we will use the lechon ancestral church, lechon, which is the answer earlier. Instead of repeated multiplication, it uses fraction expansion with powers of 5. The decimal is expressed as fraction with denominators in powers of 5. So the whole number is over 2, 5, 25, 125, 625, and 3125. Combine it into one fraction. Then to compute it, we're going to multiply it based on its place. For example, 1's place is 1 times 3 and 1 times 3,125. So the equals is 3 over 3,125 because the denominator and numerator will multiply to its place. And next is this 5 place. So 5 times 1 and 5 times 625 is equals to 5 over 3,125, and you will just repeat it 5 times, and after you repeat it in 5 times, all the numerators will be added. So the answer is 2083, and the denominators will remain the same, which is 3,125. So to check it, we need to compute it to 3,125 divide 2,083. So the answer is 0.666. That means we got the right answer. In creating the ALA enumeration system, one major challenge was making it both mathematically function and culturally meaningful. Since it uses base 5 instead of the familiar base 10, we had to rethink place values, arithmetic operations, and conversion. For example, 4 plus 4 is equals to 8 in base 10. In base 5, it becomes 13 because 13 is the base 5 of 8, which shows how arithmetic rules change and can be confusing at first. And another difficulty was using cultural icons that reflect Batangueños' identity while remaining it simple for computation. When writing the number of 20, in base 5, it will become the Lomi and Ancestral Church because Lomi symbolizes 2 while the Ancestral Church symbolizes 0. Symbols carry both cultural and mathematical meaning, so it's confusing. The ALA enumeration system offers several advantages. It preserves Batangueños' culture by embedding local heritage into mathematics, making learning more engaging through familiar icons that simplify base 5 concept. It also fosters creativity, critical thinking, and problem solving while promoting multicultural education by showing how numeration system can adapt to culture and be compared with other like decimal, binary, or Mayan. However, it also has limitation. With only 5 symbols representing large numbers, it requires strong grasp of positional notation. Non-local students may struggle to connect with the icons, and arithmetic operation in base 5 are less intuitive and more time-consuming than in base 10. Additionally, converting between alae and decimal slows down the calculations, and its culture's specific design limits broader adoption outside the Batangas. And as a group, we learned many lessons from creating the ALA enumeration system. First, all systems share the same principle. They rely on place value and the base. Second, the base changes the rules. In base 5, we carry and varo at 5 instead of 10, showing arithmetic's flexibility. Third, numbers can be cultural. Using Batangueño's icon prove that numeration can reflect identity, not just math. Fourth is design needs logic and creativity. We balance mathematical rules with meaningful cultural symbols. Fifth, we appreciate other systems. Exploring base 5 connect us to Mayan, Babylonian, binary because of their bases. The numbers is not just a numbers. They can tell stories, express cultures, and show identity.